Hello students. In addition to those main lesson videos, I created some additional videos to help you out some homework problem set. And the problem we are going to talk about in this video is number 14, section 5.1, number 14. It's a required problem, so everybody has to do it anyway. Here we go. Section 5.1, and we are doing problem number 14. And how does it go? We have differential equation t squared y double prime plus ty prime minus y is equals to t to the 1/2 power. And of course t has to be greater than 0 because this is a square root. Inside of the square root has to be positive. And then in this case, we are looking for a particular solution of this type. C times t to the 1/2 power. So this is t to the 1/2 power. So we're making an educated guess. Particular solution could be some constant times t to the 1/2 power. Will it work? It probably will work in this case, but it doesn't always work. There are some adjustments to be made if you have something different over here. In this case, it'll work. This, by the way, is going to be a part of rather typical technique that you're going to employ in, let's see, what do you call it? This is not variation of parameter. I don't know, some kind of substitution or some kind of guesswork, educated guesswork to find that particular solution. Okay, let's begin. Particular solution must be of this form, all right? And what about the derivative? Let's find out. Apply the derivative. So this is going to be 1/2 c times t to the negative 1/2 power, all right? Second derivative is going to be, take one more derivative, then that's going to be negative 1/4 c, and the t to the, let's see, subtracting one more, negative 3/2 power. I guess those are the derivatives to put in. So, okay, we are ready. We're going to put in this one, particular solution right here, and then the first derivative right here, and then the second derivative right there, and we're trying to find our c value. Let's see how does it work. So t squared, and then we are plugging in this one in. Okay, all right. That takes care of the first term. Next, t times this, and then y is of this form, and that should be equal to t to the 1/2 power. Okay, can we do some further simplification? I guess we can, because this second power and times negative 3/2 power, then you'll simply add up the powers. So this is going to be negative 1/4 c times t to the, let's see, second power minus 3/2 power. So this is 1/2 power. And then multiply by t times that first power, negative 1/2 power. So we have t to the 1/2 power again. Oops. And then c times t to the 1/2 power is equals to t to the 1/2 power. Okay, do you see something in common? Of course, t to the 1/2 power is common. If that's constantly 0, then of course we'll have a just single point, t equals 0, but then again, t is greater than 0. We don't have to worry about that. So remove all those, then I'm gonna get, let's see, let me take shortcut, just copy and paste, and then remove these 1/2 powers, 1/2 power, 1/2 power, and then e equals to 1. And what do we have? We have an algebraic equation to solve. Solve this equation, you're going to get C value, and that will be your particular solution. Well, let's see. Even though this is a required problem, I got thus far, this much, so why don't I just complete this problem. So negative 1/4 plus 1/2, so this is going to be positive 1/4 minus c is equal to 1, isn't it? Negative 1/4 plus, okay. So this is equivalent to negative 3/4 is equal to 1. Okay, so what do we have? C is equal to negative 4/3. Unless I made some mistake, looks like this is the answer. So what do you get? Particular solution yp of t should be negative 4/3 times t to the, oops, wrong key, 1/2 power. So we got it. Okay, does it work? Well, let's find out. Clear the variables, and then let's define y of t as negative 4/3 t to the 1/2 power. And then let's copy and paste the left-hand side of this differential equation. T squared times y double prime of t, second derivative, plus t times y prime of t, first derivative, minus y of t. And let's mathematically calculate it. And do we actually have the right-hand side, t to the 1/2 power? Let's see if that is the case. Yes, we got it. Square root of t, which means this computation we did and this answer are correct. I don't mind if you just end up copying this and then submit it as a homework problem. It's okay as long as you take each step and then learn these things and try to do the same for the next problem, which I'll not help you.